This is the first video in a series where I explain how to design game assets using Autodesk Inventor. Now, normally you do not want to use a CAD program such as Inventor to design game assets. However, if you are reverse engineering existing models, then it can be of great use. So the first thing we want to do is design a high resolution model. First, we want to create a project file. This is important because later when we are creating a low-res project, then these two projects have to be separated. Otherwise, you might run into problems. So in order to create a project file, go to File, Manage, Projects, and click on New. Then select a new single user project. Next, create a name, for example, CAD example, and select the directory where you will place all your part files. So just browse for that. I'll put them in here. And here you can see where the project file is created. Click Next. Nothing to do here. No, and finish. Okay, so you might run into this warning. That's fine. The active project cannot be changed while Inventor files are open. Okay, so just click on Done. That doesn't matter. We can just actually close this file here because I didn't do anything. So the first thing to keep in mind is that you want to create all your models using the same basic orientation. For example, all models have the default view being front on, or all models have the default view of being viewed from the top. Now, to help with this, it's best to create a ground plane. So you can't view that right now, but if you create a new part, then I can show you how that's being made visible. If you go to View, and then here you can select Ground Plane, and now the ground plane is visible, and you can just see that right there. The same goes for assembly. If you're working with assemblies, you generally want to switch on the ground plane, so you are sure that all the models are created in the same orientation. Of course, you can see this also at the cube right there, but I find using the ground plane, it's just a little bit more easy to see. So let's start with an example. If we create a simple sketch right there, and for example, let's make just a rectangle like that. Extrude it. Right. Now, let's say you want to bend this part. The way you normally would do that in Inventor is just add another sketch on top, add a line like that, and go to the bend feature right there, or you can use sheet metal as another option, and then it will bend. If we just add a bit of a lower radius, and it's a bit better to see what I'm getting at later on. Okay. So now this is not how you want to bend a part. I will show you why. This is the high resolution model, but when we are creating the high resolution model, you always have to think about what happens when you are creating the low resolution model. Because normally when you create a low resolution model, you just delete features from the feature tree, and that's it. So you create a high resolution model, delete and then copy it. I will show how that's done later on, but with the low resolution model, just go through the feature tree and you delete everything, all the surface detail basically. So all the things which can be replaced with a texture. Now, if you want to reduce these rounded edges here, because they can be replaced with a normal texture, that really cannot be done now, because if you there's nothing to delete in the feature tree. If you delete the bend part, I can just simulate it by moving the end of part file up, then the model will return to its original position. Now you don't want that. So instead of bending a part using the bend feature, model it just so that it's basically at the right angle, and then use fillets instead to simulate the bend. Here, let me show you what I mean. Let's create a new part. And basically do the same thing. But instead of bending it, just use the sketch to outline the shape like that. And extrude. Okay. Now in this case, we can just add fillets like that. And with this, we can simulate the bend. One here and another one at the other side. Of course, you can calculate exactly what the radius of the fillets should be so that it looks just like a bend, but I'll just eyeball it right now. You see? So basically this looks the same as a bend part, but now if you want to create a low resolution model later on, you just delete these fillets in the feature tree, and then it can be replaced with a normal map. The other thing is when you do add fillets, then if you can, then you should select the G2 fillet right there. Because the difference is that when it's rendered in a game engine, such as Unity, then it looks much smoother. In Inventor, it's not necessarily easy to see the difference between the two, but you can definitely see the difference once it's in another 3D application. You could also remove the outlines, and it could be a bit better visible. Basically, the transition is smoother. But when designing, it's usually better to keep this setting on shaded with edges. It's a bit more clear. So let's delete this for now. Another thing to keep in mind is that when you add a cylinder or a circular shape to a flat plane, then you need to apply a few modifications. Let me show you what I mean. Let's add a cylinder to this plane here. Just add a sketch, add a circle right there, and then extrude it. Okay. So this looks fine in Inventor, but when you take this into 3D Studio Max, then it will look something like this. So it will create triangles at the base of the flat plane right there. And you don't want that. Well, there might be situations where you want that, depending on how your lighting works and maybe some other special effects, but in general, there's no need for that. You don't want these extra vertices here. So the way to solve that, well, there's two ways to solve that. You can you can use two different parts and then add them together in an assembly. That's one way. And another way is to split them up. So in order to use the split feature, first you have to add a plane to the plane here, a plane with an offset of 0. Then use the split feature here, use the bottom option there, split solid, and as the split tool, just select the plane right there, and press OK. And hide the plane for now. You can't see any difference right there, but if you take this model into 3D Studio Max, then it will look like this. So now the vertices on the flat plane have disappeared, but you will still have additional vertices at the bottom of the cylinder, because now these two parts, they have their own surface. So what you want to do is delete the surface on the bottom of the cylinder. So in order to do that, just hover your mouse over that area, and then there will be a drop-down list, and just try a few of those. Just hover over it, and then you can see that this is the face you are looking for. Select it, and then just click on delete face right there. Okay. Again, there's no difference you can see in Inventor, but if you bring this model into 3D Studio Max, then it will look like this, and this is what you want. So there's no extra vertices on the flat plane, and there are also no extra vertices at the bottom of the cylinder. So that's that. Now next, when you are creating dynamic objects or objects which can move, then you have to keep in mind where the pivot point is. So basically the pivot point is at the origin, right there, center point. So if you would move this object in Unity or any other program, then or 3D Studio Max, if you would just rotate it, then it will rotate around this point right there. If you first create your object and then discover that the pivot point is not at the correct location, then you can still move it around, but it's a bit messy. So it's best to think about this from the start. So let's say you want the pivot point to be in the middle here. Now in that case, and for example also in the middle here, and when you create a sketch, then you have to right there. Then you have to move it right in this location. So so the pivot point is right there. So instead of putting it here, then you can just let me just delete these points, these lines here. For example, you can you could put it in the middle instead here. And just use a constraint there, hover over the middle right there, and then over the center point. There you go. So now it's in the middle. So now if you look at the if you highlight the center point, you can see that it's in the middle. Same if you want this to be in the middle of the object or on this line here, then you have to think about what happens when you extrude this. Edit feature. See, it's extruded from this plane here outwards, but if you extrude it from the middle, right there, oops, this one, it looks the same, but then if you select the center point, then you can see it's actually in the middle right there. Okay, next, materials. So when you are creating the high resolution model, then you can use as many materials as you want. The materials in Substance Painter, they don't have any performance cost if you apply more of them. Normally, if you apply more materials in 3D Studio Max and or also in Unity, then this is not good for performance. However, in Substance Painter, basically multiple materials on one object are simulated using different textures or different parts of the texture. So this can be easily transferred from Inventor to Substance Painter by the use of ID maps. So in Inventor, you can just apply a different material for every face. You can apply one material for this face and another one for that face, and you can use as many materials as you would like. The only thing you have to keep in mind is that you should avoid using metal materials in Inventor, because many of the metal materials provided, either a Autodesk material or an Inventor metal material, it's very difficult to extract the metal color from it in 3D Studio Max. So when an ID map is generated, it really can't differentiate between different metals. So you might have one metal which is gold and another one aluminium, but if you convert it to an FBX file, then they both look the same color, and if an ID map is generated, it's the same. It looks it might generate the same color. So the best thing is just to create your own material library. Don't use any metals, and it doesn't really matter how it looks because all the materials will be replaced anyway in Substance Painter. One thing to keep in mind with materials is that if you use mirrored parts, then this can create problems when you apply materials due to, I'm not sure if it's a bug or a lack of a feature, but I will show you what I mean. Let's say we create this part here, let's save it and put it in our folder. And then, okay, this one can delete. Create a assembly file. Save this one. Okay, so place the part we just created inside. Okay, so to mirror this part, we just go to the mirror feature right there, select the component, mirror plane right there, next, insert in assembly. Okay. Right, so then open this mirrored component. And save it. Initial save, yes. So now we have two different parts in our assembly, one original one and a mirrored one. If you are working with the mirrored part, then and you want to add a material, then always make sure that when you add a material, you have this this part here selected. You can recognize it with it's got an icon of a circle with a square inside of it. You have to select that and then add the material. For example, here, change it to gold. Go to the assembly, and there we have it. If you don't add the material whilst this icon here or this part here is selected, for example, you just select this one there and then you add the material, this can create problems later on. So if you ever run into problems with materials and mirrored parts in an assembly, then just first of all clear all the materials by selecting just the entire tree right there, and then click on select all, better, and okay, you see this clear material icon there. In fact, if that doesn't work, you just select another one like this one also, and then click clear, and then it says there's actually nothing to override. But yeah, first clear all the materials and then select the correct one. So this icon right there, and then apply the material. Save it. Okay. Another thing which is important is that if you add a hole in a surface or an extrusion, then you should always add a fillet, otherwise it will create normal baking errors. So let's create a hole in the surface right there, just using the circle feature, extrude this the other way, and then right there. Okay, so when you bake an object like this will definitely create wavy lines in your normal map. So in order to solve that, just add a fillet like this, and make sure it's big enough so it basically engulfs the low resolution or low poly lines which go around the edge here. So this will prevent any normal baking errors. Of course, when you are reverse engineering an object, then this might not always be possible. But when you can, add a fillet to a round surface. Same with an extrusion right there. If you can, just add a fillet. This will prevent any normal baking errors. If you want to add some text to a surface, this is easy to do by just adding some text to a sketch and then embossing that into the surface. For example, here, I can add some text right there. If you want to change the height of the text, you have to select it first and then change it. Okay, so there it is. Finish the sketch. And using the emboss feature, emboss this into the surface. Now you want to make this as shallow as possible, for example 0.001 millimeters, because if it's any deeper than that, then this can create any small skewing errors in the ID map you're baking, or you can get some small artifacts in a normal map. So it's like this. There's our text. If you want to give the text a different material, which you definitely want to do, otherwise it cannot show up on an ID map, then there's a few ways to do this. What you don't want to do is select each surface and give that a different material, because that can take forever. Control click. If there's a lot of features, a lot of text, and this just takes too long. So instead, what you do is you click on the emboss feature, right click, go to properties, and then out of the feature appearance list, select the material you want to use. And there is our material right there. Another thing you want to keep in mind is that if you want to add fillets to a model, then you want to do that using the fillet feature and not do this in the sketch. And let me show you what I mean. So let's just create a new part. Just make it very simple, like a rectangle. Let's give it some dimensions. No matter what. Let's say we want to add some fillets using the fillet feature right in the sketch. So, for example, like this. Now, if you extrude this, then it looks like a regular fillet, except there's nothing to delete in the feature list. So this is not so easy to, these fillets are not so easy to remove when you want to make the low poly model. If you want to do that, you have to find a sketch here, open it, edit sketch, and then either move this to 0, and then it's not really clear what's happened here. If you put it back to 10, then sometimes the sketch can go all over the place if it's not constrained. So that's not really a nice way to do this. So instead, what you want to do is you just create a square like normal, and then use the fillet feature right there to add the fillets. Because if you do that, then it's much easier to remove later on. So let's add these fillets right there, done, and then you can just delete this feature. There you go. Also, if you want to add an object to the assembly, then you really want to put this at least in the center of the assembly. So let's first add the ground plane right there. This really should be always on, so it's easy to see where the objects are located. And then when you add objects, then just constrain them to the origin. There's a couple of planes and axes, and the center point here you can constrain the objects to. Now, by the way, here you can see that this object here doesn't have the embossed text in because it's not updated. So if you click on the update button here, then you can see that all these other features appear. And you can also see that the text is mirrored. So if you're working with text, then it's best to add this later in the mirrored object. So first mirror the object and then add the text. Right. So finally, if you run into problems with materials, the thing to do is go to the Manage tab and click on first on Purge. Then if there's any materials which are not in use, they should end up in this list, and you can click yes to all and then OK. And also, you want to update all the materials. Click on Update, same if there's something to update. Or first also you have to select the correct material library, the one you're using. Select yes to all and OK. If that doesn't work, if there are still problems with materials, then you also should make sure that the update icon is not highlighted, so there's no updates pending. And if that doesn't work, then you can click on Rebuild All. Rebuilding all can take a very, very long time depending on the size of your assembly, so it's really a last resort. So that's basically it. I hope you enjoyed. If you have any questions, just post it in the comments below, and thank you for watching.